1.
So before lunch, we found our GCF by multiplying all the common prime factors, and we found that it was 16. And that makes sense because factors are smaller than the numbers that you begin with. Well, the smaller two are equal to. Least common multiple has to be larger than the numbers you begin with, or equal to. Okay. So we're looking for numbers that are larger than or equal to. So what's a strategy I could use to find my least common multiple? Naya? That would be for the GCF. I'm looking for the least common multiple. Yes, Adrian? Okay, that makes sense. So he's basically just saying, think of what is 32 times 1, 32 times 3, 32 times 4. Another way you can do that is repeatedly add 32 to your previous product. So this obviously is 30 equal to 32 times 1, right? So what would 32 times 2 be equal to?
64.
Don't be shy now, 64. Another way I can think about that is, well, heck, just what is 32 plus 32? 2 plus 2 is 4. 3 plus 3 is 6. What would the product of 32 times 3 be? Well, it's yeah,
96.
I agree, because 3 times 2 is 6, and 3 times 3 is, okay. Now, typically, you always want to find the multiples of the smaller number first. Why is that? Because if you're lucky, the smaller number is a factor of the larger number. Let's see if that makes sense. What is 96 times 1?
96.
Okay. So is 96 times 1 equals 96? So 96 is also a multiple of 96?
Yeah.
Okay, so that's where the equal to comes from, right? Is there any point to me finding multiples of 96 when I see 96 is over here?
No.
Let's look at the word, the acronym LCM. What does L stand for?
Least
C?
common multiple.
Okay, so this is a multiple. All these are multiples. Common means same. Is 96 equal to 96?
Yes.
Okay, and I don't see any number smaller than 96. That's a multiple of 96. 96 is the first multiple. So this is automatically my LCM. There's another way with prime factorization, but honestly, right now, this is probably the easiest, most efficient method for all the numbers that you guys will see. Once you get up to big nasty numbers, you'll probably need the prime factorization method. But all right. So what's the number one thing to keep in mind whenever you're thinking, what's the difference between GCF and LCM? Okay, multiples have to be greater than or equal to. Factors always need to be less than or equal to the numbers that you start with, okay? Okay, that's good. You know what? Hold on. Something's not right here. The GCF of 32 and 96, I don't think should have been 16. I think it should have been bigger. Why would I say that? Everyone needs to pay attention. I just said, I don't think 16 is the greatest common factor of 32 and 96. Why is it not the greatest common factor? We must have made a mistake someplace. Anyone for table 2 or table 1 see why? What mistake could have been made here? Ozil? Maybe. Jose?
When you were multiplying, you just got the number 3.
Okay, when I was multiplying, I forgot the number 3. I don't think I forgot a 3. I think I forgot a 2.
No, those were 2, so you made it 4. Oh, yeah. And there's 1 3 left.
But let's look at this. I just proved right here that 32 will go evenly. In other words, it's a factor of 96. Is 32 a factor of 32? Yes, it's equal to. Right? So if 32 goes evenly to 96, shouldn't 32 be the greatest common factor?
Yes.
I wonder what we did before. I wonder what mistake we made.